Okay, so I think the setup, I mean, first off, right, we're trying to find a place where there is zero electric field. Anywhere in between here, there's going to be an electric field. It couldn't be zero, and that's because the charge at this point would be attracted to that one, repelled by that one, and there's no way for them to add to zero. Likewise, on this side here, although we would be attracted, say a positive charge might be attracted to this guy and repelled by this guy's closer, and therefore the force would always be stronger both because it's a bigger charge and because it's closer, right? And so there will always be a rightward electric field here because there's no way this guy can overpower that one, okay? But if you look at this, on this side, there's a possibility that because this guy, and the electric field due to this guy would be away from it, but it'd be toward this one. If you're close enough to this one, you're far enough from that one that its size is overpowered by the proximity of this one, right? So it's possible for it to happen over here, right? Now the setup isn't that hard. Okay, what we're going to do is we're going to set the electric fields equal, right? And when they're equal on this side, that's when it would be zero, because this electric field would be due to Q1 would be that way, right? The electric field due to Q2 would be this way. So when they are equal in magnitude, that's when they would be there'd be zero, okay, because they're in opposite directions. So let's just set this thing up, right? Let's go K times 25 E minus 6, right? Oops, failure, okay. And that's over X squared, right? Equals K times 50 E minus 6 divided by, okay, let's see, this distance is X plus 0.12 squared, okay? So our formula, the formula for electric field is KQ, whoops, over R squared. My Q tried to become something else, okay? So KQ over R squared is our formula, so this is KQ over R squared, so R would be this, right? KQ over R squared. Now, obviously, the K will cancel out, right? And we don't need to worry about that, right? And you could merrily foil this thing and get like a giant thing with all these terms, right? Let me humbly suggest that we do a trick that I saw when I looked at the solution guide to this, okay? Let's do the square root of both sides, right? And then this is much nicer. If you take the square root of both sides, you're in much better shape. So square root of 25e minus 6. Square root of x squared is x, right? Equals square root of, 50 e minus 6 divided by, okay? This is much nicer. Our first instinct might be to just foil that, but just don't. Okay, so now you're set, right? If you square root both sides, now you just cross multiply, separate, get all the terms with x on it on one side, and then you can solve for x. Should get 29. Hope you do. You could do it with a solver too, couldn't you? Go this minus this is 0.